In this lecture, I discuss about resistance, resistivity, conductance and conductivity. First of all, we discuss about the resistance. Resistance resistance of conductor is the natural property due to which it opposes the flow of current. That is, the property of conductor due to which it opposes the flow of current is called resistance. It is generally denoted by R, capital R. Its SI unit is SI unit of resistance is ohm. Circuit symbol. In any electric circuit, resistance is represented by the symbol given in figure. It is the property of conductor due to which it opposes the flow of current. And the another property of conductor which support the flow of current, it is termed as conductance. Conductance. The reciprocal of resistance is called conductance. It is generally denoted by K. K equal to 1 by R. SI unit of K, ohm inverse, or it is written as MHO, mho. The dimension of resistance. Dimension of resistance. Dimension of resistance, we have V equal to IR, R equal to V by I. Dimension of V is M L2 T minus 3 I minus 1, yani M L2 T minus 3 I minus 2. Dimension of conductance. Dimension of conductance. It is a reciprocal of resistance. Therefore, reciprocal of dimension of resistance is M L2 T3 I2. The resistance of conductor depends upon following factor. The resistance of conductor depends upon following factor. Resistance conductor depends upon following factor. Number one, length of conductor. Length of conductor. Resistance of conductor is directly proportional to its length. If L equal to length of conductor, then R proportional L. Number 2, cross sectional area of conductor. Cross sectional area of conductor. If A equal to area of conductor, so 2 A equal to area of conductor, then the area of the resistance of conductor is inversely proportional to its area. If A is area of conductor, then R varies inversely A. Combining these two equations, we get from equation first and second, R varies inversely L by A, or R equal to rho L by A, where rho is constant, which is called specific resistance. Or resistivity. It is defined as by taking L and A unity, that is L equal to 1, A equal to 1 from equation third, R equal to rho. Resistivity. The resistance of unit length and unit cross sectional area of conductor is called resistivity. SI unit of resistivity. Since rho equal to RA by L, RL. SI unit of resistivity, ohm meter. Dimension of resistivity. Dimension of dimension of R M L2 T minus 3 I minus 2 into L M L3 T minus 3 L minus 2. The next term is conductivity. Conductivity. The reciprocal of resistivity is called conductivity. It is denoted by sigma. That is sigma equal to 1 by rho. SI unit of sigma. Ohm inverse, meter inverse. Dimension. Dimension of sigma. M minus 1, L minus 3, T3, I2. In other words, resistivity also defined as the ratio of electric field and current density is called resistivity, or the electric field per unit current density is called resistivity. That is rho equal to E by J, where E is electric field and J is current density. We have E equal to V by L and J equal to I by A. Then from equation first, rho equal to V by I The next term is Ohm's law. at constant temperature, the potential difference between two ends of conductor is directly proportional to current flowing through the conductor. If V is the potential difference and I is current, if V equal to potential difference between the ends of wire and I equal to current flowing through it, then V proportional I or V equal to Ri, where R is constant, which is called resistance. Plotting the graph I versus R, I versus V, we obtain the straight line. The nature of graph is a straight line. Ohmic resistance. The resistance which follow Ohm's law is called ohmic resistance. Its VI graph is a straight line. For example, metallic conductor such as aluminum, copper, silver, gold, etc. Non-ohmic resistance. Non-ohmic resistance. The resistance which does not follow Ohm's law. The resistance which does not follow Ohm's law is called non-ohmic resistance. Its VI graph is curve. Example, vacuum tube, junction transistor, junction diode, etc.